Welcome, welcome. We are going to give everybody a minute. We're getting a late start tonight, but we are here for Work It Out Wednesday. And we are starting off with a simplifying expressions problem. And we're going to give everybody a minute to join us tonight. As usual, if you have any problems, you can drop them in the chat for us. You can email to help@mathematicstutoring.com. We are always here to help. I'm going to go ahead and jump right in to our first problem of the night here. And we're going to get harder as we continue tonight as well. I'll move my paper. All right, so let's get started. We have 3x plus 5x minus 2x. So we are just simplifying expressions. So one thing to note about expressions do not have the equal sign. So that's why we do not have an equal sign here. So for this expression, it's a simple one, and I just wanted us to get started. We are combining like terms. So all of these have x in common. So that means they are like terms. So we are going to kind of use some of our order of operation rules. I like to keep it, we're going left to right with our addition. So 3x plus 5x gives us 8x minus 2x we're going to bring down. And then 8x minus 2x leaves us with 6x as our answer. So that is a pretty simple one for simplifying expressions, but we are going to kick it up a notch. So now what happens when we add a little more to it and also add some non-variable numbers as well? So here we have 3k minus 4 times 2k minus 3. Well, we know because we have a 4 on the outside and we're thinking about order of operations, we want to distribute that 4 first. So we are going to distribute. So we will get, and I like to just rewrite what we originally have. And we're going to treat this 4 like it's a -4 because it has that minus sign. It takes on that 4. So that -4 times 2 gives us a minus 8k. And then since it's a negative times a negative, that gives us a positive. So 4 times 3 gives us 12. And so we're going to continue. We're simplifying, and this is an expression. It doesn't have a welcome, like we said, equal sign, like we said. So we're going to do 3k minus 8k, and that will be a minus 5k. And I like to tell students same sign add, different sign subtract. And since this 3 is a positive and the 8 is a negative, we're really subtracting, and you give it the sign of the bigger number, which was the 8 here. So that's why it's a -5. And we're going to bring down the 12, and that is the answer for our expression. So that will be -5k plus 12. And then we have one more for you here, because we all know, everyone says it, we hear it all the time here at Mathematics Tutoring. I don't like fractions. Everybody complains about fractions. So what do I have for you? I have fractions tonight. So sticking with those simplifying of equations right now, we are going to do a -3/5 a plus 2/5 a minus 4. Okay. And same thing, we always want to combine our like terms. And right now we see that we have -3/5 a plus a 2/5 a. And our -4, it'll just be by itself because it does not have a constant in it, so it's by itself. So really, we're just changing this here. And so it's going to be the same, just like we usually say, hey, if we have a negative and a positive, we are going to subtract. That's the same here. Because we have a -3 and a +2, we're going to subtract these from each other. So a 3 minus 2 gives us a 1. And we take the sign of the bigger number, which will be negative. And since they had the same denominator, it was simple. We got to keep it anyway. A minus 4 would be our answer. So don't let those fractions intimidate you. It's still as if we are working a regular problem. Would you like to see one more fraction problem before we move on to something else tonight? I'm going to do one more. And I'm going to make it a little bit harder too for us tonight. Yes, please. Oh, thank you, Jessica, for joining us tonight. And Lydia, thank you so much. And please let us know if you want us to work anything additional for you all tonight. Thank you so much for joining us. Again, we truly appreciate the support. So now we have 7 minus 2 times 1/2 x minus 3. And we all know we first want to start off with that distribution. So we're going to distribute this 2 to both of our numbers. And I know somebody might pause and say, how am I going to multiply that 2 by that 1/2? Well, we all know that the 2 really has an imaginary 1 underneath there. And then when we multiply fractions, we multiply straight across. So that's really 2 over 2, which we also know we can reduce that to 1. But I'm just going to leave it as 2 over 2x for right now. And we'll reduce it on my next step. And then that 2 times -3 here will be a +6. And remember, as always, this minus sign here latches on to that 2. So when you're distributing, you want to distribute that minus sign out. And that's how, since we have a minus and a minus, it turns into a plus. So now we're on our step, we combine like terms. Well, what's like here? Our 7 and our 6, because they don't have a variable like our x value. So really we are doing 7 plus 6, which is 13. And like I told you here, 2 over 2 is 1. So we're going to have minus x plus 13 as our final answer. All righty. So I know fractions can be intimidating sometimes, but definitely don't let them intimidate you. You can absolutely do it. All of the rules are just the same. All righty. I am going to, if we have any questions in the chat, please drop them in the chat. I am going to move us to some subtraction tonight with our students using the break apart method. So we have 24 minus 17, and we are going to break both of those numbers apart. We get so many families that ask us about these new math strategies and how they feel like they are a lot. Lydia, great question. So we are live generally at 7 o'clock on Wednesdays, 7 to 8. Sometimes just based on our schedules, we might push back to 7:30 or so. And so tonight I had something, so I pushed back. But because I know you all are looking for us, we are here tonight a little later. But yes, every Wednesday we are here. So please join us. Tell a friend, bring a friend. We will be happy to work out your problems. So like I was saying, a lot of parents find the new math sometimes challenging, or like, why are we doing all of these extra steps? Or how am I supposed to know this for my student, and things like that. So I definitely Oh, yes. Yes, that new math, second grade. I have a second grader too myself. So I like to also share and show those strategies here. So this break apart, I tell families, first off, let's think about place value. So I'm going to review you on your place value. This is our ones place. This is our tens. So what does that mean? That means this 10 here is really 20. Okay. And that one just stays 4. Well, we're going to do the same thing for our 17. Let's break that up to 10 and let's break that down to 7. So perfect. We've broken it down and we're going to take the time to now add what we know. We know 20 plus 10. That's something simple for our students because we're just adding zeros here. So we're really just adding the first number. So now we have 30. Okay. So then we can go here. We have 4 and 7. So you can either have your student just add 4 and 7, or you can even break down this 4 some more, which our friends will know is 3 and 1. And why would I do that? Because now we could do 3 plus 7 is equal to a 10. And so we know 30 and 10 is equal to 40. And then what does that leave us? Because we've used our 7, we've used our 3, we're just adding 1. So now our student gets 41. And I know that looks like a lot of steps and things, but this is really good for our students who maybe they don't have their fact families down just yet. But here at Math-A-Matics, we are firm believers in yes, we use the new strategies. Yes, we use the new ways, and we want students to understand this, but we do believe in learning your facts too. So still grab those old school flashcards. I do them with my son all the time and practice so that your student knows automatically what 4 and 7 is and things like that. So it really even helps them in breaking the numbers down when they do know those facts too. I am also going to show another way for the subtraction tonight too for second grade, which I did with my son for his homework this week as well. Let me grab a problem. Alrighty, so we're going to do 93 minus 21. But this time, we are going to, Jerika Chambers says, I'm confused. Were you confused by the break apart method? Do y'all want me to do another break apart method before I move to a different kind? I will oblige. So, Jerika. Oh, she added instead of subtracting. Yes, Jerika. So, what we want to try to do for our babies with the break apart method, it's all about using tens. And did I add instead of subtract those numbers? I did actually. Actually, I was supposed to. You're right. You're right. I missed that. I was supposed to use addition to get to our subtraction. That's what I was supposed to be doing. I'm gonna have to redo that again. um, so I will show that way actually again using that. So I'll do that first for you and then do this way. Yes. Okay. So great catch, Jerika. I appreciate that. We can break these apart into 90 and 3 and then 20 and 1. And so what we can do, we're adding backwards to get to, we're adding backwards instead of subtracting to get to our numbers. And so that's what you do with this break apart method when you want to do addition to get to subtraction. So what do I mean by that? So we know that if we are at 20, 20 plus what will give us 90 is what we're really asking ourselves. And that will be 70. Okay. And then we will take this 70 because our goal, right, is we want to get a 93 here. So we know that 70, we're 3 short from here. We know 1, which is from our 21, plus 2 is equal to 3. Stick with me. So that we know that our 70 plus our 2 is 72, which gives us our 93 and our 21. So 72 would be our answer. And I'm going to show that to you. And this is actually how you're using breaking apart with the addition. And so you broke that 21 down and you're trying to build up to your 90. And these are the two things that equal to get that to your 90. And that's how you do it using subtraction. I know that's a lot to that, which can be confusing. But if you're reminding your student that your goal is to achieve your bigger number and using your smaller number, the pieces that you can. And so that's a little bit easier for them than something where maybe like you had to regroup or things like that. Okay. Any questions out there? Please feel free to share. And thank you, Kimberly, in the chat tonight. All right. Now, I'm sure this might be another one that some of our parents have seen out here. And this is what I did for homework with my student this week. And we used a T-chart for our tens and our ones. And so visuals are so great for our students. So we have 72 minus 5. And we know we're going to draw 5 ones here. Okay. And then for our 72, I'm going to do those in another color. We have 1, 2, 3, 4, 5, 6, 7 tens. And then we have 2 ones here for that. Well, we know that we can't, and really I should have flipped that actually, my dots. So our 2 ones are really on top. Well, we know our 2 ones, we cannot take our 5 red ones from our 2 green ones. So we're going to give this 10 right here to our 2 ones. So we're going to add 10 to that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then now we're going to take those 5 reds away or connect them to one of our greens each time. And what do we have left? We have 1, 2, 3, 4, 5, 6 left. 7 left because 12 minus 5 is 7. And we have 67. And so that just gives our students a visual diagram, and if they cross out correctly, how to subtract. And this is a really good first step to helping your students visually see regrouping. So we know that that 2 is smaller than a 5. So sometimes kids don't necessarily understand what's happening when we do our old school way of canceling out the 6 and just giving it a 1 here and making it 12. Sometimes they don't realize that's really a 10 that we got from over here. And so this way is showing them what is really happening. So this is a great way to start your student, and then you can teach them your old school method if you would like to from there, for sure. All righty. Do we have any requests, Kimberly? Thank you, thank you, thank you. All right, so awesome. I'm so glad to hear. There's so many methods out here, and giving visuals is like such a great thing to give to our students, especially when in second grade, Miss Lydia, they're going to move to those 3-digit subtraction, and it really helps them set the foundation that they're understanding what's happening. And especially when they have to move across zeros, if they understand visually what is happening and that you're breaking that 10 apart and you're giving it to your ones, and 10 from your hundreds and you're giving it to your tens place and things like that. So I'm glad that you liked that strategy. All righty. Well, algebra is highly, highly, highly requested here every week. And we are going to jump to some algebra problems, unless anybody else has any requests tonight. We are going to solve some slope. So the first question we get all the time is, what is slope? How do we find it? And there's so many ways that we find slope. So I always like to start off by explaining our slope. Oh, we would love to have you back next week for sure. All righty, so slope, let's do the basics here. So even last week we talked about it. Y equals mx plus b. This is the equation of the line and one of the foundations for algebra, period. And so our m is our slope in our equation. Our b is the y-intercept in our equation every single time. So when we have a simple problem, and I'm just going to write one here, y equals negative 5x minus 1, our slope will be negative 5. And one thing about our slope, as I'm breaking this down tonight, is that m is equal to rise over run. So even when you see that we have a -5, we really have an imaginary 1 down at the bottom. And this rise over run, because slope connects to graphing, think of it as you're rising, meaning like you're standing up out of your chair, and you're running across. So that's really y over x when we're going to graph it. And it's important to know how to identify it and the ways, but then it's also important to be able to solve it. And we can solve it from a point, we can solve it from a graph. And so one of the ways that we are going to solve it tonight are using 2 points. We get this all of the time. How do we solve from 2 points? So we know that slope is equal to y2 minus y1 over x2 minus x1. And so we are going to find the slope tonight of 8, 10 and -7, 14. And so the first thing we want to do, like our equation, we want to label. And which it doesn't matter which one you choose as your y2 or your y1. And so even this one I'm going to choose. This is my x2 and my y2. And this is going to be my x1 and my y1. It's just you have to be consistent. So we're going to plug those into our equation. So m equals 10 minus 14 over 8 minus -7. And since we have a negative next to a negative, that turns into a positive. And so now we solve, and we use our same integer rules when we are solving for these. We're having a positive, same sign, add different signs, subtract, and give the sign of the larger number. So since we have a plus here and a minus, we have different signs, so we're subtracting. So that will be 4, and the absolute value of the larger number is 14, so it will get a negative here. And then we just have 8 plus 7, so it will be 15. So our slope of our line is equal to -4 over 15. And from here, we actually can even find the equation of the line, if we wanted to, by plugging it back into the y equals mx plus b equation. And if I can do that. So we will do y equals -4 over 15 plus b. And so we will use one of our original points, which was 8, 10, -7, 14. So I'm going to use the 8 and 10. And so we're going to plug them in. So for y was 10 is equal to -4 over 15 times 8 plus b. And you see, we can solve that because we only have one variable missing. And when we have one variable, we can solve an equation. And like I said before, we know this is multiplying. Under every whole number, there is an imaginary 1. That's the one thing that you want to make sure that you know in algebra, is that there's always an imaginary 1 under any whole number. It can change adding fractions for you, multiplying fractions for you. It can really bail you out and make these things simpler. So we are going to do 8 times 4, or our -4, which will give us a -32, and it'll be over 15. And we have 10 plus b. And again, we want to isolate our b because we're just looking for the b in our equation. So we will add that 32 over 15 to our other side. So we will get, I don't want to skip steps. Oh, can you see? 10 plus 32 over 15. This is kind of large for us, and we know that there is a 1 under that. I'm just going to do some quick cross multiplication here to solve. So 10 times 15 gives us 150. 1 times 32 gives us 32. And we know that would be both under 15. And we're going to add those together. And so we will get 182 over 15, which I'm sure of it, we can simplify. So we're going to divide 15 into 182. We know that 15 can go into 18 one time. And that leaves us 32. So it could go in there 2 times. And that will be 2/15 left if we want to. And 2 over 15 is like 0.13. So this one was a little doozy. So our ending equation will be y equals negative 4 over 15x plus, we could say 12.13. But that is how you can get an equation when you use 2 points to get to a line. And I know people think that algebra can be challenging. It's just sometimes the steps that you have to do. We got a request for order of operation. All right, let's jump into it. Thank you so much for your request tonight. We absolutely appreciate you all tuning in. I'm going to make sure that I'm seeing this right. And I'm going to make sure, and Kimberly, let me know if I'm getting this right. Is this 8 divided by 2 times 2 plus 2? Is that correct? Okay. I'm going to see if I can grab one of our strategy guides real quick. Because we like to use our strategy guides for order of operation. And here we go. I think I found it. So for order of operations around here, we like to use GEMDAS, or we like to use PEMDAS, but whichever one you are the most comfortable with, you absolutely can use it. And I'm going to show it to you. And we're going to look at it as we go. And so in our strategy guide, we have it right here, GEMDAS. So it stands for groupings and symbols, our exponents, multiplication and division. And when multiplication and division, they're really at the same part. So it's left to right, and addition and subtraction. So as we do the problem tonight, we are going to be referencing this page and our steps. So first, the G for groupings. Well, we have a parentheses here of 2 plus 2. So we're going to do that first, which is 4. And I'm going to leave the parentheses until we do this. And because this 2 is multiplying by this parentheses, that's actually why we would do this first. So that'll be 8. And then now we're just left with dividing. So our answer will actually be 1. And I'm sure there's some controversy out here, because there always is controversy when it comes to order of operation, of someone saying that we should have divided 8 by 2 first. But because this parentheses just can't go anywhere, and this is really, if you think about it, like our 2 distributing first, that is also why we would multiply our 2 and 4 first before we would actually do our division. And those are ways that you can yes, Jessica, there is I've never not seen controversy with order of operation. There always is. Somebody always has a different answer. Okay. But yes. And this page that I showed can be found in our math strategy guide for 5th grade. And we even give you an example breaking it down and highlighting the steps. That is exactly why it goes viral all the time. And this one, I mean, I'm old school, so I like, please excuse my dear Aunt Sally. This one is graciously excuse my dear Aunt Sally. I just love it. I love it. I love it. People also like to argue you should do 2 and 4 before, but that's multiplying now, not grouping anymore. Yes, absolutely. And we're supposed to do those groupings first. And when we say groupings, we're meaning we have to do what's inside of those groupings first, for sure. Any other requests? Would they like to see another one tonight? Let's take 2 more problems or topics. All right, let's take 2 more. Okay, we have a request for another one. All right, let's get into it. Let me get us something. Okay. I have one for us. Not sure what grade that was because I did not see exponents. So I am going to do one that does have exponents this time for sure. All right. All right. So, oh, you all cannot see my paper. Just give me one quick second. I'm sorry. Alrighty, so let's do this one. Let's do 2 times 5 squared minus 10 divided by 5. We are going to still use our GEMDAS rules again. So one, we don't have any groupings here. So we can move on to E for exponents next. And so what exponent do we have? And in case some people don't know what an exponent is, it is 5 squared is our exponent. And what this really means is just 5 times 5. And so we know 5 times 5 is 25. And we're going to just rewrite and bring everything else down. And so sticking with our GEMDAS here, the next is multiplication or division. And like I said before, they're on equal playing fields. So we go from left to right of our problem. So left to right, well, left, we encounter 2 times 25 first, which we know is 50. And then this is subtraction, so we're just going to rewrite that. And then this is our 10 divided by 5. So now we are actually going to divide 10 divided by 5, which will be 2. So we're going to get 50 minus 2. And now it says addition and subtraction. So 50 minus 2 is 48. Making sure you can see that, and I'll walk us back through. So we had multiplication here, so we got our 50, and since we had division, because we worked left to right, we divided that 5 divided by 10, which gives us 2, and now we do our last step, which is subtraction. So whenever you are doing these problems, it is a great idea to drop these steps near you and just walk yourself through them as you encounter each part. It really helps a lot. All right, I think we might have time for one more tonight. Any topic, any problem, and then we will see you all next Wednesday. If we don't have anything in the chat, we will see you all next Wednesday. Definitely email your problems. Oh, wait. I think there's one more coming. All right. With multiplication, and he's in the 4th grade. All right, awesome. So let me ask this. 4th grade, is it 2-digit multiplication? Is it decimal multiplication? Right now they're working on division. Oh, okay. And if we're struggling in multiplication, division can get hard. So let me help you. So one thing that you can help your students with, and I'm just gonna make up a problem. If you have a problem that you want to throw out, go ahead. I'm gonna make something up, and I'm gonna show you a strategy that can just help your student kind of work through problems since they need a little strength. Awesome. Okay, so let's say 7s can give our babies a lot of trouble. So I'm just going to make up something with 7. And I promise I'm literally just making these numbers up off my head, some of my favorite numbers. Okay. And he may not even be doing 4 digits yet. He might just be doing 2 or 3. Well, no, more like 3 in 4th grade for sure. So we're going to do this 7 is dividing into this 2,959. Well, when we have students that are not that proficient at our multiplications, we have to support them. So one way I do that, or I like to see my students do, is making a T-chart. And we choose numbers that they can work with. So we choose 1. We choose 2, and we choose 5. Why do we choose that? Because students can usually get to those things. We all know 7 times 1 is 7. Well, if they don't know what 7 times 2 is, they can add 7 plus 7. Most of our students know that. That's 14. Now, when we get to 5, they still may not know that, but everybody usually knows the clock, and they usually know how to count by 5s. So we can go 5, 10, 15, 20, 25, 30, 35. And a lot of the times our students do know their 5 multiplication facts. And once we have that, we can stretch this even more by just adding a 0 to all these. So that's 10, 20, 50. And literally your students don't even have to know that's 70, that's 140, that's 350 right there. Now they have created their own things that they can use to divide this problem. And so we can do this in a few ways. So we could take this a step further and do this as a partial quotient, is what we call it when we break it down. Or they could even just use this T-chart as they're going through the numbers. So we know I am about to open a door. I am. The door is open, wide open, but I'm not going to get it too complicated. I'm going to keep it simple for our family that's looking to help their son. Okay, so we are at, when we talk about partial quotient, we're going to draw us an extra line here. And so we have this 350. We could even take it another notch, especially since we have such a big number here. 100 will become 700, okay? So then what your student could do, we are going to subtract, since I know that 100 is 700. And that's a 100. And we're going to put this 100 off to the side. So that gives us 9, 5, 2, 2. Well, I'm going to do it again. So we get 9, 5, 12, 15. I'm going to do it again because I can see that 700 can subtract still. And you're telling your student when they're doing this, until this number is smaller, no worries, no worries. Until this number is smaller, then we're not going to move up our T-chart yet. So we're going to just keep subtracting the 700, and for every 700 we're taking out, we're putting 100 here because that's how much we've done. So now we get a 9, we get a 5, and we get an 8. Well, 859 is still more than our 7, so we could get one more 100 out of there, and I hope y'all can see. So we get 9, 5, 159. So now that we're at 159, we're going to use that T-chart. Up 140 is still smaller, so that's 20. So we're going to subtract by 140. So we get 19. Now we're at 19, where we're going to use our T-chart. Up 14 can come out of that 19. And that leaves us 5. And so that was 2 that we took. Well, 5 is smaller than 7, so that is going to be our remainder. And I know that's a lot on this screen. Hopefully y'all can still see that all. And so now what your student is going to do, they're going to add this all up. And if you notice, I kind of kept my numbers by place value so that we'll make it easy. So that's 2, 2, and then 1, 2, 3, 400. So 422. Remainder 5. Now in 4th grade, they're not doing remainders yet. That's more 5th grade, but it's just showing you, because I just made this up on my head, how while we may not be super skilled at multiplying yet, to support us in our division, we can make this T-chart, and it gives us confidence. It gives our student and builds their confidence because they have the answers right here, and they don't have to struggle as much to get through that. And this is called partial quotient division. They do have to interpret it. Listen, we teach so much math here that all of these grades jumble up sometimes for me. But okay, I'm glad to remember. I know they multiply decimals in 4th grade too. And so yes. I hope this helps. Oh, absolutely. And definitely join us again on another Wednesday. On next week, we will be here. Please, 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 Kim, will you drop it in the chat? Email your problems, email your homework. I just told a friend, she was like, girl, I watched you on Work It Out Wednesday. I was like, oh, I love that. She was like, I'm going to start sending my sons all his homework. I said, go ahead, bring it on. We want it. We want to work out problems because you're not the only family that needs this support and that needs to see some different strategies out here. And we are happy to be that resource and support. We are Math-A-Matics tutoring. We do educational consulting. We do online, one-on-one live private tutoring. And we also sell our digital products as the strategy guide I showed you tonight, just as a resource for families so that we can as a resource to families. So even when we're not here on Wednesdays, that you can pull out that strategy guide and you can support your student on your own. Even sometimes when we don't have all the answers, it can be a support to you. As always, thank you for joining us tonight, and we really appreciate you all. And we will see you next Wednesday, and we will be here at 7 o'clock next Wednesday. Have a great evening. Bye-bye.